Hello students, today's agenda is to check homework. We'll be learning about central and inscribed angles. I was going to include some more, but it seemed that it was a little too much, so only those. And you will be able to work on 9.2. Today, students will be able to find angles in circles formed by chords, radius, and it says tangent lines, but those are the ones that we're going to see in the next lesson, okay? So let's start by having some information. We already learned about arcs, and we're gonna learn something about, when you have an angle formed from the center to an arc, that's called a central angle. So it touches the center, okay? That's very important. And we also have inscribed angles. Those angles also have the same arc, but they go and touch all the way or the vertex touches the circumference of the circle. Okay, very important. Central angles touch the center, inscribed angles touch the circumference. So what is the relationship between these two? Well, central angles are twice the inscribed angle. Okay, that's something that we need to know. And it's congruent to the arc. So for example, if this inscribed angle, which is half the central angle, if this inscribed angle is 44 degrees, remember that inscribed angle is half of the central angle. This is half of that. So if this is 44, this will be equals to 88 degrees. Okay, the inscribed angle is 44, central angle is 88. If the central angle is 88, the central angle is always congruent to the arc. Okay, so if it's in the center, these two will have the same measurement. So this is 88, this also will be 88. Okay, now what if we didn't have that information? We only had this or even this, then whenever they give us either the arc or the central angle, then the inscribed angle is half, so you just divide by 2. For example, in here, this arc is 110. If they were asking us for the central angle, that will also be 110, but we don't even have it in here. However, they're asking for x, which is the angle, the inscribed angle, and that is always half of that. So 110 divided by 2 is 55. So this x is 55 degrees. Okay. Okay, we have here some more examples. It says, find all the angles and arcs. This gets a little bit more tricky, so we have to be very careful. Let's see. Okay, it's already zoomed in. So we have lots of information. We have 3 different measurements of degrees. We know that this is a central angle. So we can figure out A, because since it's the central angle, these are the same. So A is equals to 45 degrees. The next piece of information is this inscribed angle. This is half of this. That means that I can multiply this by 2. This times 2 gives me from here to here. Okay? From here to here. And how much is that? Well, if this is 55, this is going to be 110 degrees. However, we already know that from here to here is 45. From here to here is 45. So that means that this, all you have to do is subtract 110 minus 45 gives me how much would that be? 65. Okay, the other way to do it, if they ask you to show your work algebraically, is B plus A, which is 45, equals 110, because we know that together that makes the arc of the inscribed angle, which is 110. If we're adding 45, the opposite is to subtract 45. And so B is equals to 10 take away 5 is 5. That is 0. 10 minus 4 is 6. And so that's the 65 degrees. Finally, we know that, and that's going to be the tricky part, to identify really what's going on. From here to here is 110, right? From here to here is 110. From here to here is 125. So we know that every circle is always 360. So letter C, and you can just add in the calculator 110 plus 125, that's 235. Subtract that from 360 and you will get the answer. Or you can just say C plus 125 plus, so this plus this whole thing, which is 110, equals 360. So C plus 10 and 25 is 35. 100 and 100 is 200, equals 360. If I'm adding 235, the opposite is to subtract 235 from both sides. And so C is equal to, we borrow, 10 minus 5 is 5, 5 minus 3 is 2, and 3 minus 2 is 1. So C is equals to 125 degrees. Okay, so we already found all the degrees of the different angles and arcs. Okay, something else that we need to note, that if you have a quadrilateral inscribed in a circle, we will say that opposite angles of the quadrilateral add up to 180 degrees. Okay, so having that in mind, and this can get really messy, so we'll see how clean we can keep it. Opposite angles equals 180. So if this is 90 degrees already, because of this marking, means 90 degrees. Let me see if I can zoom a little bit. There you go. So if this is 90 degrees, the opposite is going to be 90 degrees, because 90 plus 90 equals 180. Okay? The other thing is that this line right here, we know that that angle is touching the circumference, right? It's touching the circle, has this line, and this other line, or chord, I should say. Okay? That means that the arc is from there to here. And remember that if this is an inscribed, then that arc over there is always double, twice as much. So if this is 90, all of this is 180. So we can say that E plus 120 will give me 180. If I subtract 120 from both sides, my E will be equals to 60. Okay, so this is 60 degrees. Okay. Maybe it would be better if I had this arc, this darker. Again, whatever is not covered from the circle, that's double of this. Okay, what else do we have? we have to figure B. So we need, that's the angle B. So let me form it with this too. So that means that this is half of that arc. Okay, I think that if you cover whatever is outside of that angle, the inscribed angle, it's easier to identify the arc. So all of this together is what? We already have that this is 60 from here to here. This is 90 from here to here. So together, what is this together? 90 plus 60 is 150 degrees. Inscribed angles are always half of the arc. So what is 1/2 of 150? It's 75 degrees. Okay, so we can take this away because we already figured that one out. Now, having this definition in mind, we can figure out D. Okay, why? Because it says that opposite add up to 180, so these are supplementary. Or supplementary, not sure. So 75 or D plus 75 degrees equals 180. If I subtract 75 from both sides, D equals, this borrows. So 10 minus 5 is 5, 7 minus 7 is 0, and you just bring down the 1. So D is 105 degrees. And finally, the only one that we need now is letter C, which is this arc from here to here. Okay? I should have used a different color, but that's okay. So we know that from here to here is 150. From here to here is 120. So what is left? We can say that C plus 150. Now I need to zoom out. Not in, out. Okay, 150 from here to here, 120 from here to here. So that's those two together. Plus C, all three give me 360. C plus 150 and 120 is 270 equals 360. And if I'm adding 270, the opposite is to subtract 270. And so C is equals to 90 degrees. So that's one way to figure it out. Okay, this is just working. I don't want it to get confused to that, with that. Another way to figure it out, and let me cover it. If I hadn't done that, let's pretend that I didn't know that it's 90 degrees. This is 90 degrees. This is the arc. We know that the arc of an inscribed is twice this. So if this is 90, this is going to be 180. So from here to here is 90, so that the other 90 will give me the 180. Okay, so that was a different way to figure that out. Okay, so with this, now you can do 9.2 and have fun.